I'm just saying. Okay, so remember with arithmetic, we first did the sequences, and then we did problems, and then we did arithmetic series, which is the sum. Good, total sum. So we just finished geometric sequences, we did geometric problems, and now we're going to go do geometric series. Okay? Now, because we're doing 2 lessons today, we're going to kind of just touch on the important things that we need to know. So the first thing is these formula things, right? So we have these 2 formulas to know. Now the other ones just switch A with T1. Now, let's start off with what do we need to know for both formulas, no matter what? A. So we need, for this one, we need A. Here we need A as well. Okay? So that's not going to help us tell the difference when we're going to use which formula. What else is common? R. Good. You need R. Anything else common? N? No, the top one needs N, right? You need A, R, and N. What do you need for the second one? Tn. Okay, so why don't we go through this? For the main reason that I hope you're using your study sheet and you're making these kind of things, okay? You always want to be knowing what to use and when. If you're like, I don't know when to use this formula, when to use this formula, then you haven't figured out the little things, right? The details. Okay? Now, let's go and do to example 2. Okay? Determine the sum of the first 15 terms of the geometric sequence -5, 10, -20. Okay, what do you know? What's -2? R is -2. What else do you know? A is -5. No, we don't know Tn. We know N. Okay? Tn would be if they showed us the last term. Okay? So this is our first time going through this, so I'm going to write down the formula. Sn equals A bracket R squared minus 1 all over R minus 1. Okay, so I'm looking for S15, right? So A is -5, and then you're going to have a bracket. And then you're going to go -2 to the 15. Now, do you notice how all of -2 is in brackets? If you don't do that, you will get these wrong. And I'll show you why in a second even. Okay? Now, to be able to pull this off on your calculator, you got to put brackets around the entire top, and you got to put brackets around the bottom. Okay? Now see if you can get the right answer. This, don't take for granted that once you get it in there, you're actually going to get it right. Some of you guys are making small little mistakes, and I can relate. Those are the things that kill you, right? The small one little bracket. And the other thing is, make sure you know the difference between a negative sign and a minus sign. Okay? That's what I had to figure out in the last class. The student was putting everything in perfect and getting error. See this here? That's a negative. That's a negative. That's a minus sign. That's a negative, and that's a minus sign. Your calculator treats them very different. Okay? Now you may say, oh, that sucks. I don't like that. Okay? Well, that's what you're taking into your exam. So you got to know how to use it. So I'm going to teach you how to use that thing so much in the next 2 years that it is going to become like the checking tool, the answer getting thing that you will be using for your diploma. And remember, that diploma is worth half of your mark in like 3 hours, right? So you need to have every advantage going into that thing. And you will have every advantage going into that thing. Okay, what are we getting? Negative 54,615. Now, why did I say that you need to have this here in brackets? I want you to just try something in your calculator. Just type this into your calculator, negative 2 squared. What do you get? Negative 4. Isn't negative 2 squared 4? See, you have to tell your calculator, I want you to square it all. If you don't put the brackets, it'll just square the 2, and then the negative just stays there. So like I put on the board, now these are things that you have to get out of your system too. You have to know these two are not equal. Okay, does everybody see that? These are not the same, because this equals negative 4. This equals 4. So if you don't substitute with the brackets, and it's a even exponent, you will always get that question wrong. And that sucks. You know what you're doing, you put it in the formula, you know your A's, your R's, all that, but you can't use that little black thing with buttons, okay? And that little black thing with buttons, if you're not using it every day, like it, I know it looks like it's not much, a little plastic thing, $100 at Walmart or whatever, but it can do a lot of stuff. I mean, I've been using it for a long time, and I still probably only use maybe 20% of what it can do, okay? Because that's all we need for grade 12, right? But you can use it in university, and it's got some programs and stuff in it that are pretty good. I mean, just because it's a hunk of plastic that you buy at Walmart, it's still actually a little computer. Now, let's do example 3. We are going to determine the sum of this one. Okay? Now, these are good examples to show you how these things work and when to use what, right? Okay, so what do we know? We know A is 4. We know R is negative 3. We know Pn is negative 8, 7, 4, 8. Okay? Now, what is the formula I'm going to use? Sn equals RTn minus A all over R minus 1, right? Okay, so Sn equals negative 3 times negative 8, 7, 4, 8. I'm going to minus 4, and I'm going to put that all over negative 3 minus 1. Okay, so make sure I have a set of brackets there and a set of brackets there. And you're getting negative 6560, right? Nice. And let's just all pretend we all got it. Yeah, there's no powers in that one. Here, let me see it quick. Yeah, you did exactly what you're not supposed to do. See, this still, it should be minus 4, not negative 4. See, I did that whole speech, and she's like, what? Yeah, probably wasn't important. I'll just move on. Okay, this one here. In geometric sequence, the fifth term is 1024 and the common ratio is 4. find the sum of the first 7 terms. Now, I'm not wasting my time here doing any redundant examples. The first and second one use the 2 formulas. Why am I showing you this one? What's different about it? No A. Do we know R? Do we know, like, which one are we going to use, Tn or the N? What are we looking for? Yeah, I think Tn's not going to help us here at all. If we knew S7, or T7, yeah, we do Tn, right? But we're going to use this to help us find A. I know N is 7, right? So we don't have to find N. So we actually know, but right now, let's use the old formula P5 equals AR to the 5 minus 1, right? So what's T5? It's 1024. What's A? I don't know, or I wouldn't be doing this. What's R? 4 to the 4. Now 4 to the 4 is 64? 256, right? 256A, right? Now divide both sides by 256, and you will get 4 to equal A. Okay? Now I know A, R, and N is 7, because they're asking me for S7. So S7 equals A is 4 times R, which is 4 to the 7 minus 1 all over 4 minus 1. Now this one, A and R are the same, so there's a lot of 4's in there for that reason. Okay? And just to save time, I'm just going to tell you the answer, because the answer is the easy part, hopefully. You get 21,844. Okay, one more example. Now this one is a golf ball off the building. So again, you guys have the pleasure of seeing me draw. Okay, this is our building. A couple windows in there. Because of time, I do not have time for all the windows. And there's a golf ball. No, it is not to scale. Okay? Unless that was a really small building. Now, here is the ground. Okay? And we're going to draw the ball going down. How high is it going back up? 3/4 of that, so we kind of want to do that to scale sort of thing. Okay, now, this would be like bounce 1, bounce 2, bounce 3, bounce 4, bounce 5, bounce 6, bounce 7. Okay? Now, how high is it falling? I guess we should start there. So this one's 100. How far is it going to bounce back up? 75. So this is 75, and then it bounces. And then what would the next bounce be about? We'll do one more bounce. 56.25. Okay? Now, the first question says, determine the height of the ball after the 7th bounce. So after the 7th bounce, this question is asking this. Okay? That's that. Does everyone see that? Okay, now that we did last day. So I'm not going to go through that again. That's just finding t, the actual value. The next question asks, what is the total vertical distance after it contacts the floor, it contacts the floor for the 7th time? Now, here's why I drew it all, because I need you to understand how we're going to do this. Now, I need to find all of the distance that it went, that it traveled, not just that little part. I need all of it added together. Okay? Now, what I'm going to do is, first of all, I'm going to ignore the 100 right now, okay? And I'm just going to count all of the ups. Okay? Now, just for sake of not getting things confused, I can do all with the green highlighter. So there is 1 up, 2, 3, 4, 5, 6. Now, it says, what is the total? So how many ups does it do before it contacts for the 7th time? See, here is the contact of the 7th time. So do you see how many ups does it do in that entire time? 6. So this is my plan. Just follow along with me. I'm going to do this so number 1, I'm going to find total of all the ups. Okay? And only because you're here, you're going to understand what he's talking about, ups. Okay? That's the greens. Okay? Now, what could I do to get all the downs? If I took that and multiplied by 2, would I get all the downs with it? Oh. Okay. I would get all of these if I multiplied by 2, right? And then add 100, I will get it all. So what I'm going to do for step 2 is I'm going to multiply the ups times 2. Because now I get the up, down, up, down, up, down, up, down of the bounces. And then after I do that, 3, I will add 100 to step 2. So whatever I got in step 2, I'm going to add 100 because I haven't counted the 100. The 1 and 2 just gets my, like if I was actually now, or maybe I should do this. If I did this in, this is a nice color. See, that would get me these and these. That would give me all those distances. Sorry, that should be green. Okay, so the ups, just green. The number 2 would give me all the green and the purple, right? And then I would add that to it. So I would have this, this, and this. It's questions like these that a smart board with different colors is really nice to have. Okay? Because now you can see exactly visually what we're going to do. Okay? So let's do that. Let's do step 1. We can do it right beside. There's lots of room here. How am I going to get all the ups? What should be my formula to use? The one with n. Yep. Okay. So I will have, so for S6, because I'm doing sum of the 6 ups. Okay, and I can even put that in here. There's 6 ups. So S6 equals 75 times bracket 3/4 to the 6 minus 1 all over 3/4 minus 1. Okay, and for that height I get 246 246.606. Can you see it in there? 246.606. That is the total of the ups. Now, if I want to get the ups and downs, I'm going to take that and I'm going to multiply by 2. 2 times 246.606 dot 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 gives me 493.212 dot dot dot. Step 3 now, I have to add 100 to it. So 493.212 plus 100. Therefore, my total would be 593.2 meters. Okay, so you can see how you have to be so organized to be able to do a question like this. You got to keep track of everything. And I'll tell you, if you want to do better on a test, bring highlighters with you. The diploma, if you see my students, they'll come in with highlighters because they have to differentiate these kind of things, right? So you want to make sure you got everything. And you can get everything by doing what I just did here. Again, if you're one of those people that no matter what you do, you can get 100% on anything, you're probably not going to step that up because if it ain't broken, don't fix it, right? But if you are one of those people that's always struggling with these sort of things, put this stuff into place and you will be much more successful, okay? Because remember, if you're not succeeding and you keep doing what you've always done, that's the definition of insanity, okay? I don't know, have you ever seen a fly trying to get through a window? Okay. Come back the next day. You know what you'll find? A crusty little dead thing right by the... Like, he just doesn't figure it out. He's like, I got to get outside. Bang. Ooh, that hurt. Okay. Oh, I got to get outside. Bang. That hurt. Okay. At what point does the fly go, you know what? This window, there's something here. I got to find another way. Okay. And some flies do it. We've seen it. Okay. They will get out of the house. They'll do it. The genius fly, you know. But you don't want to be that dead crusty thing. Okay. So for your assignment, that's all we're doing for that one. Okay, where are we here? I got to go back one. Yeah. So your assignment is 1 to 7, 10, 13, 18. Okay, and make sure we don't move too fast because we have one more lesson to do. Lesson 8. Now, we were just working with what you call finite series. There was a start, there's a finish. It's very easy to find the sum when you know it ends. Well, we're going to actually work with infinite geometric series. So, can you find the sum of something if it goes on forever? Okay. Can you or can't you? Well, sometimes. Today's where you're going to learn when the sometimes is good or bad. Okay. Now, let's go to page 78. Now, we're talking at the very, very, very top. You see we got a little bit of room in there? I have a little bit of room too. We're going to write, there's two types of series. One is called the convergent series, and the other one is the divergent series. Okay, so I'm just going to be moving sideways. So this is what a convergent series looks like. 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 dot 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 dot. Now this is what a divergent series looks like. 1 plus 2 plus 4 plus 8 plus 16 dot 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 dot. Okay? So you need to know the difference between them. What do you notice? What is the R value for the convergent? It is 0.5 or 1/2. Okay, so list this R equals 1/2. What about the divergent? R equals 2. Okay, now the divergent series, you see how it's getting bigger and bigger and bigger? What is the infinite term? We don't know. So if we're adding it, we're not going to ever find the sum. Now you would think maybe the same for the convergent. But the convergent, because it's getting smaller and smaller and smaller, there's a point where all that other stuff doesn't even add to the sum anymore. Like if you took 1/2 of 1/1,000,000, right? You're not going to get very much. Okay? And I'll show you how this works later. But so for a convergent series, R must be less than 1 and greater than -1. In other words, it has to be a fraction or a decimal. Okay? Do you guys know how to read those? You read from the inside out. So R has to be less than 1 and R has to be greater than -1. Okay? Now for a divergent, R is greater than 1 and less than -1. Now people always get messed up with what's less than -1. Give me a number less than -1. -2. Okay? Now right away people go, but -4 is way smaller than -1, right? -100 is way smaller than -1. People ignore the negative sign and go, what? 100's way bigger than 1. Well, I didn't say 100 and I didn't say 1. I said -100 is way smaller than -1. Okay, because the negative is way, way, way more left on the number line, right? Now, this one, you can find the sum. Okay, this one cannot find sum. You can't find the sum of something if we don't even know what the last term are. The terms are just getting bigger and bigger and bigger. Okay? So the way you do find the sum of the convergent series is by using this formula right here. I don't know if that makes it just where you can't even read it. I'm going to do it in yellow. Okay? Now, there's actually, you could use two formulas. You could use this formula here as well and just put like 100 or 200 as the end. And you'll see, I'll show you later how that works. So this is for finite geometric series. We will use either these two. Now, I don't like that second one because they just switch the 1 r to the n minus 1 and 1 minus r to the n. They just switch that around. Okay? Now, the other thing Remember, finite, they end, so you use those two. Now for infinite, if it's convergent, you want to use this formula here, S equals A over 1 minus R. If it's divergent, there is no sum. You cannot. Sum doesn't exist for something that just keeps going forever. Okay, so let's figure out what I'm even talking about here, okay? So let's go to this question here. Let's do A. Now, again, I want to find the sum of all those things, yet they go forever. I'm going to show you something here. Let's use the finite sum formula, and let's do 100 terms. Okay, so let's do 100 terms. Let's say if we add up 100 terms, okay? So let's do this. Let's do S100. We'll do 100 of this. A is 1, okay, and that's going to, R is 1/3 to the 100 minus 1 all over R, which is, 1/3 minus 1. Okay, everybody try putting this into their calculator and see what they get. And then you're going to have to math enter. Math enter to get it to a fraction probably after. But so I'm adding up 100 terms. That's going 1/9, and then it's going to go 1/27th, and then 1 over 81. It's just, but you see how 1 over 81 is even a pretty small fraction? That's to get smaller and smaller. Anybody got anything yet? What are we getting? 1.5, yep. 1.5 is, in fraction, 3 over 2. Okay. Now, did anybody do that in one step? Okay. Can you hit math enter again? Math enter should bring that back. Did you bring it back? Should bring back all the math you did. Because if you did the same question but you put 200 in, just try it quick. Put 200 instead of 100. Now, if you hit math enter, you actually, or second enter, I should say. Second enter brings back your old stuff. With 200? Yeah. You shouldn't have got syntax error. You should still get 1.5. Maybe the operator. You didn't put your top in brackets. Okay. So, I'm showing you that. Now, you know the formula they give us? Let's try it. A over 1 minus R. A is 1. So that's 1 over 1 minus 1/3. What do you mean you didn't get that? I just put stuff from the formula in there. R is 1/3, right? This equals 1 over 2/3, which equals 3 over 2. Okay? So you can either use the finite formula to like 100 or 200, or you can just use A over 1 minus R, which I was just kind of proving that they both work. And if you put in 200, you still get the same answer. If you put 500, you get the same answer, because those ones are so little down at the end that they don't add to your sum anymore. Okay? Now, let's go down. We're going to do this one last question. We're just going to do B. 1B. So find the sum to infinity of the series of 0.07. Now, I want you to try that into your calculator. Go 0.07777, do a bunch of them, and then hit math, enter. Enter. Okay, make sure, well, you don't have to go nuts, sir. Go math, enter, enter. You get 7 over 90 using your calculator, right? Now, the first thing you're asking me is, okay, so we're done. Well, I want to show you using, this is a good question to show you that this is actually an infinite series. Now, you know it's infinite because it's got the little thing on it. But I'll give you one on the exam where your calculator won't do it for you. It won't just give you the 7 out of 90. So I want you to see how to do it. Now, this is the same thing as 0.07 plus 0.007 plus 0.0007 dot dot dot, right? That's the same thing as above, is adding all those. So now I have made an infinite geometric series. Now what is my A? So A equals 0.07. What's my R? Not 10, because 10 times 0.07 is 1 over 10, which is 0.1. Okay, so now I can use my infinite formula to get 7 over 90. So this is how we're going to do it. It's, right, S equals A over 1 minus R. So A is 0.07 over 1 minus 0.1. This gives you the answer 0.07 over 0.9. Now, you're not allowed to have decimals in a fraction. It's like against the law. So I have to move the decimals the same in both of them to get rid of all decimals. Now, do you see on the top, it's going to dictate how many I'm going to go. So I got to go at least 2 to get rid of all decimals, right? So we got to go 1, 2. So you have to do the same with this one. 1, 2. So you have to put a 0 there. So then you get 7 over 90. I moved my decimal on 0.07, 2 to the right to make it 7. And then I had to, if I did 2 in the top, I had to do 2 in the bottom. You can't do 2 in the top and then 1 on the bottom. And if I would have just went 1 each, then I'd have 0.7 over 9. That's still a decimal and a fraction. So you got to go again, which is 7 over 90. Okay? So we're doing 1 to 8. Okay, so as you can see, you almost have a half hour. Don't waste your time on these. Don't start talking. Okay, tomorrow we'll be doing 2 quizzes. And we will also be working on your practice test. And this will be one homework together, because I've cut a lot of questions out. Okay, I'm just going to go back to this one here, because I forgot to scroll through the homework.